Welcome to The Explainer. Today, we're diving into a piece of engineering that's absolutely critical for safety and environmental protection out in the energy industry. It's a story all about controlled fire, precision science, and, you guessed it, some incredibly strict rules.
Just think about that for a second. You are on a metal structure, completely surrounded by water, and your job is to get rid of a highly flammable liquid, and at a massive scale. I mean, it sounds almost impossible, right? But it's actually a routine part of testing a new oil well. So how on earth do they pull it off? Well, it all comes down to some seriously brilliant engineering. The solution is called a well testing burner, and once you start to understand how it works, you see this whole hidden world of procedures and safety protocols. So let's take a closer look at how this incredible piece of equipment really operates.
So, what is it officially? Well, it's classified as Category 2.1 surface equipment. But what does that really mean? In simple terms, its whole job is to safely and cleanly burn off liquid hydrocarbons that come up when you're testing a well. It's kind of the final stop in a low-pressure system.
Now, you definitely don't just light a match and hope for the best. The process of making sure a burn is safe starts long before any oil even gets near the burner. This first phase is all about meticulous preparation, or as they call it in the industry, rigging for success.
There's a super strict 4-step checklist, and it has to be followed perfectly. In an environment where just one mistake can be catastrophic, this isn't just a suggestion, it's a lifeline. It means mounting the equipment correctly, picking the exact right nozzles, cleaning out all the lines, and pressure testing the valves. Every single one of those steps is a critical safety check.
And really, the details are what matter here. The burners are put on these massive 60 or 85-foot booms, just to keep all that intense heat far away from the rig. They do a test lift of the entire assembly just to check its balance. They run computer simulations to make sure the nozzles are the perfect size. They flush the lines to get rid of any little piece of debris that could cause a blockage. And get this, they even test the valves by pressure testing them against deliberately plugged atomizers, just to make sure they can hold. Absolutely nothing is left to chance. Okay, so once everything is rigged up and ready to go, we get to the real core of the technology. How do you get a clean, controlled flame instead of, a giant plume of black, polluting smoke? Well, the answer is all in the science of combustion. The key to this entire process really comes down to this one number, 200 psi. For certain models like the Green Dragon burner, this is the magic number. It's the absolute minimum back pressure you need. But why is that so important? Well, because that pressure is what turns the oil into a fine mist instead of big, heavy droplets.
And this visual just shows the difference perfectly. On the left, you've got atomization. You use high pressure and compressed air to turn oil into a really fine mist. This mist has a huge surface area, so it mixes with oxygen and burns completely, cleanly. On the right, that's what happens when things go wrong. You get these heavy, unburnt droplets that just fall right into the sea. That's called fallout, and it's a serious environmental hazard that this whole system is designed to prevent.
Now, to get that perfect burn, there are some rules that are completely non-negotiable. You can see the language here is absolute. Things like collapsible air hoses, forbidden. They could collapse and starve the flame of oxygen. A remote electrical ignition system, mandatory, usually with propane pilot lights. And under no circumstances, ever, are people allowed to try and light the burner manually. The risk is just way too high. The takeaway here is that automation and robust equipment are what take human error out of the equation at the most dangerous moments.
But, lighting the burner is really only half the battle. Once that massive flame is going, the job isn't over, not by a long shot. A whole new set of risks prop up, and managing them takes constant vigilance and, again, sticking to those safety protocols. This might sound simple, but it is the most important rule of all. You always operate the burner that is downwind from the rig. It's common sense, right? This makes sure that the incredible heat and any fumes are blown safely away. And what if the wind changes direction? Well, they immediately switch operations to a burner on the other side of the rig to keep it in that safe, downwind spot. At the end of the day, protecting the people and the platform is priority number one. A water shield, which is basically a giant curtain of water, is mandatory to absorb the intense heat. Sprinkler systems on the booms have to be ready to go at a moment's notice. And if anyone has to work on the boom before the burn starts, a dedicated watchman is required, someone whose only job is to watch for danger and stay on the radio. But once that flame is lit, that boom becomes a strict no-go zone, period. Even shutting the burner down follows this precise 3-step sequence, and it's all designed to prevent pollution. First, you cut the propane for the pilot. Then, you shut off the air supply. And finally, you turn off the water for the shield.
Following that exact order is critical. Why? Well, think about it. If you shut off the air first, the oil would stop being atomized, and you'd create those polluting droplets we talked about. This sequence guarantees a clean shutdown, every single time.
All right, so the fire is out, but the story of this burner is far from over. I mean, this equipment goes through some of the harshest conditions you can imagine, so its entire life cycle, from the day it's made to the day it's retired, is managed with incredible rigor.
Okay, this is actually fascinating. Most equipment like this has a 20-year lifespan, but because of the extreme thermal stress that these burners go through, they have a shorter, mandatory retirement age of just 15 years. And every 5 years, they have to go through a major recertification. We're talking a complete top-to-bottom overhaul with visual inspections, wall thickness tests, pressure tests, the whole shebang, just to make sure it's still safe to use.
And the level of detail and the safety standards is just incredible. It covers everything, even when the burner isn't being used. I mean, look at this quote from the technical standards. Something as simple as how you transport them is carefully planned out. You can't just stack them, because they aren't designed to bear weight that way. Do it wrong, and you could cause a hidden weakness that leads to a critical failure down the road.
So the next time you see a distant flare on the horizon, you'll know it's not just some random fire. It's the end result of decades of engineering, countless simulations, and a set of rules all written to protect both people and the planet. It kind of makes you wonder, what other complex hidden systems like this are working all around us every single day just to make sure our world keeps running safely?